We are going through exercise 13G, question 1B. So we need to sketch this. So as you can see, it's pretty much a stock standard log graph. The only thing that's really different here is the fact that I have a 2 out the front, which means I'm going to have a dilation by a factor of 2 from my x-axis. Now, the first thing that I'm going to do is actually find my domain. So I'm going to find my domain. And the reason why I'm doing that is just going to help me find out what my asymptote is going to be, even though we should already know. But let's just do it anyway. What's my domain? It's going to help us. So we know that when we're looking at a log graph, my argument here cannot be a negative number and it cannot be 0. So that means this right here has to be x is greater than 0. It has to be that. It has to be x is greater than 0. And we're pretty much done now. Because there's nothing else to rearrange, it's just x is greater than 0. Another way you could write this is 0 to infinity. Both of those are acceptable. Now, the reason why we did that is just to kind of reassure ourselves of what the asymptote is going to be. My asymptote is going to be x equals 0. So let's draw that in. It's going to look like this. So I come over here and I'm going to write x is equal to 0. Now, the next thing that we need to do is find my range, but we're actually going to hold off on that until I've actually drawn it. So let's now move on to the next thing, which is finding my x-intercept, And we know that we're going to find my x-intercept by letting y equal to 0. So what I'm going to have is 0 equals 2 to the log 10x. I now am going to rewrite this. So I'm going to divide both sides by 2 because I can do that. I can get rid of that 2 at the front, which means I'm going to get 0 equals log 10x. And that really just shows you that having a number out the front is not going to affect what your x-intercept is going to be, because you can simply get rid of it like that by dividing both sides by it. Now I can write this in my index form, in which 10 is my base, 0 is my power, and I set that equal to x. 10 raised to the 0 is 1. It's just going to be that. So it's your normal x-intercept. It's just your normal one. So now I'm going to give this a sketch. Wish me luck. I'm never really good at this. No, that's no good. All right, that's as good as it's going to get. All right, hopefully you can draw better than me. But this is going to be my 1, 0. So I'm going to come over here now. I'm going to put that in right there. That's going to be 1, 0, just like that. Perfect. Looking at this now, it's quite clear what my range is going to be. My range is just going to be all real numbers, remembering that your range is just all your y values. So we found my x-intercept, 1, 0. We found my range. We found my domain. And you might be thinking to yourself, are we done? And we are absolutely not done yet. And the reason why we're not done is, let me show this to you. So if you've just come from the first video, you've probably already seen this, but let's do it again. So what I've done here is I have drawn what we're after, which is 2 log the base 10 of x. And as you can see here, my x-intercept is 1, 0. But let's now change my base. So this time, instead of a base of 10, I have a base of 2, in which case it's going to be that. And as you can see, it's a different graph, but it has the same x-intercept. And we could draw it again with a different base, this time a base of 100. And yet again, it has the same x-intercept, but it's clearly a different graph. So what we've drawn here isn't good enough. There isn't enough information that would distinguish this graph from these. So therefore, what we're going to have to do is add in another point, which is going to distinguish it from other graphs. So let's now do that. So I'm just going to write in another point. That's what we're after now. We're after another point. Now, in the back of the book, what point do they use? Let me just quickly look. They use point 2, probably because we've already used 1. So they're like, all right, let's just do 2. So they said, let x equal 2, in which case, what are you going to get? So now I'm going to have to go y equals 2 log 10 of 2. Now, do you know what that is? Because I don't. So that means we're going to have to use our cas, and that's why I don't like doing this, because I don't like using my cas. Well, I do, but I do like using my cas, but if it's unnecessary, why do it? So we're going to get 2 control log base of 10 argument of 2, then control enter to get the approximate is going to be 0.602. 602, 602, y equals 0.602, which means I could put this in. So it's saying when that is that, it's going to come up here, come across here. This is going to be 0.602. Draw a line across, draw a line down, like that. Now, is there another easier thing we could do? If you've just done that, you're fine. You're golden. You've put in all the information that you needed to get all your marks. You've got your domain, you've got your range, you got your x-intercept, you got your another point, which kind of gives it scale and distinguishes it. I personally wouldn't put in that one. What I would do is I would come... It really comes to how big you're going to draw your graph as well. So, for instance, what color do I want to do this in? If we did this in purple, if I would say, you know, let... x equal 10, and if we did that, then we could say, all right, it's going to be y equals 2 log 10 of the 10, which means log 10 of the 10 is 0, so it's just going to be y equals 2. Sorry, 10 of the 10 is 1. 10 of the 10 is 1, because 10 raised to what power is 10? 10 raised to 1 is 10, so it's going to be 10 times 1. Let me just make that clear. I accidentally said the wrong thing there. So 2. Now, the reason why the back of the book doesn't probably do that is because you'd need a lot bigger graph. So you'd actually need, like, this is going to be 10, and then this over here is going to be 2. So that's probably not accurate at all. But it just shows you that when you're doing this, if you can do it in such a way that your base and argument are the same, because you know that your output then is going to be 1, it's far easier than using your CAS. But sometimes using your CAS is expedient because you can do something close to what you already know and you don't have to draw this huge graph. If we were to come here for a second and I just show you on Desmos what we've done, so let me just come over here. If I come over here and say let x equal 10 and get rid of these, and zoom out, you see how far we've got to zoom out. So that's really why they haven't done it. So this is going to be 10 and 2. And that's what we've shown here. The other one is x equals 2, far more reasonable. This is to 0.62. So maybe the backup book is onto something in terms of the size of your graph and just making it, you know, the scale somewhat realistic. This is not a realistic scale at all. You know, this is the difference between 1 to 2, and this is the difference between 2 to 10. It's just not realistic. But hopefully that shows you what's going on. And just remember, if in a test, they don't give you grid lines on your graph, but it's just simply, you know, literally a graph like that, don't worry too much about the scaling. As long as you show me 2 points, you're golden. All right, so that's probably enough for this one. Hopefully this was helpful.